Question number 2, we need to prove each of these identity. So A here, the left hand side is 1 plus secant, and then cosecant minus cotangent. So 1 plus secant is 1 over cos, and then this is 1 over sine minus tangent. Tangent is cotangent cos over sine. Okay. So this one, 1 minus cos. So this one I can change it to become cos x. So it will become 1 over cos x. I factorize, then I have cos x plus 1, and then this I factorize 1 over x as 1 over sine x, then it will become 1 minus cos x. So we have the 1 minus cos square x over the sine x cos x. Okay, because this one, okay, this multiply with this, we have the x minus y plus x. So when we multiply this, it will become x squared minus y squared. That is the x squared minus y squared here. Okay, so this one, 1 minus cos square will become the sine square x over sine x over cos x, and then cancel. Then we have the sine x over cos x, that is the tangent x. So tangent x is the right hand side. Then so we have the sine square plus cos square equal to 1. Then we have the sine square is 1 minus cos square. So we have the sine square is 1 minus cos square here. 1 minus cos square will become the sine square. Yes. This question, we have more than one way to prove it. So some students, they may do this, they just expand. So we have the cosecant x minus cotangent x plus secant x cosecant x, and then minus secant x cotangent x. Cosecant is 1 over sine. This is cos over sine. This is 1 over cos. Cosecant is 1 over sine, and this is 1 over secant. Secant is 1 over cos. Multiply with this is cotangent cos over sine. Okay, so cos over sine, sine. So this one I multiply with cos x, multiply with cos x, then I will have the this minus with this, so sine cos. So these two are the same, so this minus this, then cancel. Then we have the 1 minus cos square x over sine x cos x. Then the step after that will exactly the same with the previous one. So it is the sine square x over the sine over cos over the sine cos, and then it will be sine over cos, that is the tangent x. That is the right hand side. Yes. Okay, so sine square, so this one 1 minus cos square is sine square. Yes. Okay, for this question is similar with the question A there. So this is the left hand side, then we have a 1 minus cos x plus secant x minus cos x secant x. Okay, expand this, so it will become 1 minus cos x plus 1 over cos x minus the cos x 1 over cos x. So this one cancel, so we have the 1 minus 1 cancel, then this, the denominator is 1, I multiply with the cos x, then it will become 1 minus cos square x and the whole thing over the cos x. So 1 minus cos, we know that sine square plus cos square equal to 1, then sine square is 1 minus cos square, so this will be the sine square over cos x. Okay, so this will be the sine x tangent x, so sine x multiply with the sine x over cos x, then this will be sine x tangent x, that is the right hand side. Okay, so we have the sine square equal to 1 minus cos square. Yes. For C, we have tangent square minus secant square plus 2 equal to the secant square minus cotangent square. Okay, tangent is sine square plus sine over cos, and then 1 over cos. Okay, so this one I can do it this way. We know that sine square plus cos square equal to 1, and then we have the tangent square plus 1 equal to the secant square, and then cotangent square plus 1 equal to cosecant square. So this one will be the so tangent square is secant square minus 1, so secant square minus 1 minus secant square plus 2, so it is 1. And then the right hand side is the cosecant square minus cotangent square, then the cosecant square is actually cotangent square plus 1, so this is 1, so equal to the left hand side. Okay, so we can do halfway for the left hand side and then do until halfway for the right hand side, then we combine. Okay, so this question we can have more than one method to solve it. Okay, so this, the left hand side is the tangent square minus secant square plus 2, so tangent square is sine square over cos square, secant square 1 over cos square, 2, this one will be the denominator is 1. Okay, so we multiply with the cos square x. Okay, so this one will be sine square minus 1 plus cos square x plus cos square x. Okay, because we have the 2y, I can become y plus y here. Okay, over cos square. So we know that the sine square plus cos square equal to 1. So this will be 1 minus 1 plus cos square x, and the whole thing divided by the cos square. Cos square x. Okay, so it will become 1 over 1 but the cos square secant is 1 secant is 1 over secant is 1 over sine, and then tangent is cotangent is cos over sine. So over here, this one will be the sine square 1 minus cos square 1 minus sine square, so 2 cos square. So just now this one, instead of doing this way, okay, so this will be 2 cos square is 1 minus sine square, 1 minus sine square x. So this one also 1 minus sine square x. Okay, then we have the sine square x minus 1 plus 2 minus 2 sine square x, and the whole thing divided by this. Okay, then we will have 1 minus sine square x. At the end it will become 1 also. Okay, so this question we cannot prove it straight. We have to make it 2 part to solve it. Okay, D, we have the cotangent. So this one, the left hand side is equal to this, and then this will be the cotangent square minus tangent square. We know that the sine square plus cos square equal to 1, tangent square plus 1 equal to secant square. So tangent square is actually secant square minus 1, and then we have the cotangent square plus 1 equal to cosecant square. So the cotangent square is the cosecant square minus 1. So this is cosecant square minus 1. This is secant square minus 1. So we have the cosecant square minus 1 minus secant square plus 1. Okay, then we will have the cosecant square minus secant square, because the 1 minus 1 cancel here. So this is the right hand side. Okay, so the tangent square equal to secant square minus 1. Okay, and then the cotangent square is equal to cosecant square minus 1, and we have the x plus y multiplied with x minus y, then it will become x square minus y square. Okay.